Okay. All right. So I picked my 5 words, right? How many letters are in each word? Below each word. Well, okay. You do you. I have what? 5, 3, 3, 2. All right. So you're counting the letters in your 5 words, and then you're going to add up those letters. So I have 5. So I have 18 letters altogether. Divide by 5. That's where you're going to probably want your calculator. So my average word length was 3.6. I don't know what yours is, but something like that. Okay. Once you get your average, we're going to put all of our averages on this dot plot. This is just a regular axis, like mine was 3.6. So I'm going to put a dot here. All right, in a second I'm going to have you call out your average, and we're just going to add them all to the same one. All right? Any more time? No? We good? Sweet. Okay, Lily, what'd you get?
6.
6? My goodness. Okay. All right, you picked big words. You must have picked big words. Michael, what'd you get?
4.6.
4.6. You still getting it?
Yeah.
Okay, I'll come back. What'd you get?
4.2.
4.2.
I got one.
Oh, you got it.
4.8.
4.8. What'd you get?
5.6.
5.6.
Are we putting all the dots on?
Yes, you're adding these to yours. Benito.
4.6 again.
Another 4.6.
Yeah,
so we just
somebody-
stack our dots.
Somebody copied us.
Yeah. Dylan, what'd you get?
We're on the same
Do you
page.
have the same page?
Yeah, we only got
the one page.
Oh, I thought there was a...
Oh, it's
So
gonna be
we
like a
worked together,
partners
yeah.
thing.
Yeah, we thought we were partners.
I'll get you a copy.
Well, now I
Sorry,
gotta go.
bro. You're not, it's not,
I
okay.
was so
What'd you get?
4.2.
4.2. Yeah, I was confused. Welcome to first period. My brain is not working. So, partners too? Oh, so we need 2 copies. Oh my gosh. What happened here? Jordan?
6.4.
6.4? What'd you get?
5.2.
5.2. And partner?
5.2.
Another 5.2. What'd you get? 5.4. Okay, did I get everybody's? All right, so put those dots on there for me. Okay, if you're done with that, you're going to use now, so if we look at this, let's just have a conversation. Look at our averages. If you had to average these numbers, where do you think that average would be? We're just eyeballing, we're not calculating. Around 5?
Yeah.
Around 5? So maybe here? Okay. So maybe there. All right, so when we average our averages, we think it might be around 5. So maybe her average word thing is 5, right? But now we're going to use an actual random tool to pick the words for us instead of our eyeballs. Because our eyeballs aren't random. They actually lean towards longer words, picking out longer words. So we're going to use a little feature called random.org. If you look on the back of the lyrics page, what we've done is take the lyrics and numbered them from 1 to what? What's the highest one? 297. Okay. So we're going to switch over. Okay, so my 5 numbers are 161, 27, 296, 119, and 230. So now I'm going to go to that lyrics page that's numbered. Find, for me, word number 161 and count the letters. So that, for me, it has 3 letters. You see what we're doing here? You find your word and count those letters, and we're going to average those. Ooh. Okay, so when I average my words, I got an even 4. So you're going to average your 5 words, your word length on those 5 words, and we'll come around and get those in a sec too. All right, let's see what you got. What you get the time, Kendall? 3.6. 3.6. So add these to that second dot plot. Nicole, what'd you get?
3.2.
A 3.2.
4.4.
She got a 4.4. What'd you get, Lynn?
3.6.
3.6.
3.6.
Another 3.6. What did we see here? What'd you get?
3.
Even?
Yeah.
3 even? Okay.
3.4.
3.4. Did y'all do separate samples?
He's doing his right now.
Oh, gotcha.
2.4.
2.4.
Yeah.
Whoa.
Hold on.
I'll come back. Brock, you still working on yours?
Yes, man.
Okay. What'd you get, Bailey?
3.4.
A 3.4. Jordan?
3.
3.
4.
A 4. Who did I miss? Anybody?
Here, let me do it quick. Me again.
You didn't get a schedule?
No.
Really? Which one? Which counselor?
Two
2.2. You're off the page, bro.
I'm off the page.
You're off the dot plot. We gotta like extend that for you.
Take that, Rock.
You got a 3.4?
Yeah, you ain't special, bro.
Oh. Okay, now look at this. How is the dot plot on number 4 different than our dot plot on number 5? It's a lot lower, isn't it? Hi.
Good morning. Your AC is okay?
So far.
There's just quite a few rooms at H Hall where it's not working.
Oh, so far so good.
That email yesterday, sometimes I get random texts from my boss and ask questions. So.
It's fine.
Thank you.
No problem.
Okay.
Bye, you too. Yes. So it's a lot lower. What does that tell you about our sampling method? When we picked them,
We chose the big ones.
they're way higher, aren't they?
Yeah.
When we chose randomly, way lower. Which one do you think is more reliable? The second one. Because even though we didn't realize we had a bias in our eyeballs, there obviously is one, isn't there? What would you say, which do you think, okay, that's what we said on number 6 here. Which dot plot is different? How's it different? Which do you think is the better estimator? We said number 5, right? Number 5, because it was truly random. So looking at the random dot plot, what do you think the true average of the word length is?
3.3. Probably 3.4.
Somewhere in here, basically. Ish, right? Ish. 3.4, 3.5, something like that. That seems like a better estimator. By the way, we use a little symbol. It looks like a curly M. It's called mu, like a kitty cat says mew. It's mu. That stands for average. Mew, mew. So we're estimating our average is about 3.4, right? So we're going to estimate it around 3.4. Now, it is known that Beyonce wrote the lyrics for all of Destiny Child's songs. The average word length for these songs was 3.64. Based on your samples, do you have a good enough evidence to say that Beyonce did not write Crazy in Love? Oops. No. It's pretty close, isn't it? And the thing about stats, a lot of times it's not going to be exact. But 3.4 is pretty close to 3.564, right? It's pretty darn close. So we can't say for sure she did. But we can say she might have. We don't have evidence to say she didn't, right? If her average length was like 5 point something, we would be like, it's unlikely, right? But do we have enough evidence that she did not know? The wording is weird here, isn't it? 3.4 words, or I guess it's letters, per word is close to her known average. So we cannot exclude her. I can spell.
What does that second word say? After 3.4?
Letters per word. Letters per word is close to her known average. We cannot exclude her. All right, so this is just giving you a little taste of the importance of randomization when we take samples. Okay, can I switch the page? Yeah, okay. So on the back, this is kind of giving you the important things you kind of need to take away. There is a lot of vocabulary in this chapter. We'll have a crossword puzzle next week on just the vocab, because there's so much vocab in this chapter. So not every chapter is like this, but this one's pretty heavy on it, okay? So in the video, you may or may not have watched it, we talked about, we're in stats, and we want to know something about our population, but we realize that it's impossible to survey every individual in the population. Even the U.S. Census doesn't get every single response back, right? It's not possible. So we end up getting a sample. So from the population, we want to take a simple random sample, and we want it to be random so it correctly represents the true population without any bias in a perfect world, okay? And if we want to know something about our population, let's say it's an average or a percent about something, like what percent are brunette? I don't know. What's the average height of Richland High School students? I don't know. In the population, we use this symbol M, or mu, I should say mu, for average. Okay? If it's an average we're trying to figure out, and then we'll use P for a percent. If it's a percent, what percent female, what percent brunette, what percent athletes, something like that. Categorical data. Now, that's the population we're trying to estimate. And the reality is we won't know exactly what mu is. We will never know exactly what P is. but we use a good sample, and when you do the sample, we use a different symbol. So if it's a sample and it's an average, we call it X bar. Big words, right? X with a bar on it. X bar means it's an average, the true average you learned about years ago, but it only came from a sample, not the whole population. It's the way we can know from symbol, this isn't everybody. And then if it's the percentage, it's still a P, but it gets a little hat on it, and we call it P hat. Right? Technical words and stats, right? X bar, P hat. That's it. P hat. I have a P hat somewhere. Where's my P hat? I'll find it. Anyway, so parameters, statistics. These are called parameters. These are the measurements that are taken to represent the population, and these are called statistics. That's the name of our course, statistics, because that's what we deal with, is values that came from samples, right? Now, how do we get those values? Simple random samples are what we want. However, there are some bad form. There are some bad sampling methods that are used often. Voluntary response sample. Anybody catch that on the video? What was voluntary response? Do you remember?
Like a survey.
What kind of survey?
Online survey.
An online survey. Voluntary response is where the respondents choose themselves. Like you go online or you text whatever to this number, right? American Idol, perfect example of a voluntary response. It's not really America's Idol because everybody doesn't vote, right? It's just the sample. So, but it's voluntary response, and it can cause a problem because those people that respond actually care about the topic, right? And they usually have a built-in bias. So voluntary response is where the people choose themselves, and the convenience sample is probably what you've seen if y'all ever been to the mall. I don't know if they do this anymore, but at the mall, there used to be people walking around with clipboards. Hey, can I ask you a question real quick? Blah, 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 blah. That's a convenience sample where the surveyor chooses the people. But that could be problematic too, right? You think? If I want to know about what you think about the athletic budget and I go to a football game, I'm going to get one response, right? But if I go to that same question, but I go to a band concert, am I going to get the same answer? No. So you need it, whatever method you use needs to be uniform without as little bias as possible. But this is convenience, so we don't like it. Convenience has a built-in bias based on who you're asking. So they're easy to reach, and I would say the surveyor chooses the respondents. Okay? So these are bad forms. We don't like these. Bad form. Simple random sample. This is going to be your favorite part of this class. Y'all don't have to know this part. That's an AP thing. It's not a dual credit thing. All right? So let's look at this. Application. How are we doing on time? Oof. Okay. A sign at a local business says, rate us with 5 stars on Google and get a $10 gift card. The store manager reads the ratings to learn how people in the community feel about the business. What kind of sample is this? Yeah, why?
It's kind of biased. If you just give them a happy answer, you get benefits.
And they have to go choose to go do it online, right? Mm-hmm. They can bribe you, but you are ultimately the one that has to go online and do it. So this is a voluntary response. Why is it biased? You just said this. Because respondents are bribed to give five-star review. So it's not an honest review, is it? Look at C. If the manager finds out, okay, so they do this, he finds out that 92% of customers rate the business with 5 stars. Is that 92% greater or less than the true percent of the people in the community that believe it's 5 stars? It's greater, isn't it? Does that make sense? It's inflated, right? Because we don't even know if they're telling the truth. But if they're lying because they're lying by saying it's good. It's greater. It's greater. Actual approval rate. Okay. Now, to help reduce the bias, the manager decides to survey the next 10 customers that walk in the door that make a purchase. There's no bribe this time, but he's just asking people who walk in the door. What kind of sample is that? A what? It's not simple, it's not random, because that's convenience. Yeah, it's convenient to him, right? He has no process of randomization in that. He's just who walks through the door next. That's how I'm doing it. So this is a convenient sample. Why is it biased?
Because it's people who are in his business.
Yeah. People who enter business. They may be random or repeat customers, right? And you said it, I think it was you, Dylan. There's no randomization here. There's no randomization. So then, how can he avoid the bias? What's that? Did you have an idea? How can he avoid the bias in this?
Surveying, like, not just in the store.
Yeah, not just in the store. Like, go somewhere else, right? Neutral. So go somewhere else and employ some value or some valid way of randomization. And we'll talk about that more later, okay? Go to a neutral location and randomize. Okay? Do you think this kind of stuff happens in real life? Absolutely. There is a local dentist in this area. I was looking for a dentist a year ago.